Example 1 in our linear program. So here is when we think back of what we talked about with the linear program. We have 3 steps. We have the scenario, the linear program, and the implications. So we're going to give you an example here of what the scenario is, how to write out and solve the linear program graphically. So here's a scenario. Example 1. So a firm is making 2 types of spas, an AS spa and an HL spa. Each of these spas requires 3 components, but different amounts of each component. An AS spa requires 1 pump, 9 hours of labor, and 12 feet of tubing to produce 1 spa. An HL model requires 1 pump, 6 hours of labor, and 16 feet of tubing. So from this you can see both of them require 1 pump, but there's a trade-off now. The AS spa requires more hours of labor, but less tubing. So those are the requirements of what it takes to build a spa. In a given production period, the company is limited to using at most 200 pumps, 1,566 hours of labor, and 2,880 feet of tubing. One way to think about this is, let's just look to see what's on our inventory shelves. This is what we've already purchased and we have to work with. All right, so on our shelf we have 200 pumps, we have 2,880 feet of tubing, and we've already paid workers to work 1,566 hours. Now the profit margin for an AS spa is 350 and for an HL spa is 300. The company wants to determine optimal production plan. So when we think about writing out the linear program, what we want to think about is this right here. We want to optimize our objective subject to our constraints. So let's think about, based on example 1, what is our objective? So you own a business, what are you trying to do? Well, think of this as we're trying to maximize profits. So to write out our linear program, so the step 2, so our linear program is going to be maximize profits subject to constraints, or what we think about what's on our shelf. Okay, so that's what we want to try to operationalize and actually write out. So our profits. Well, we know our profit is equal to, it said that the profit margin, which is price minus direct production costs, on the AS spa is 350. And for HL spa is 300. So it's some combination of these two. So before we write that out, we want to be able to determine, let's let x1 equal the number of AS spas and x2 equal the number of HL spas. So now our profit is equal to 350 x1, the number of x1 spas we sell, plus 300 times x2. So this here is our objective function. And now we just need to think about what are the constraints. So the constraints are we have so much product on the shelves to be able to produce spas. So let's think of what it requires to build an AS spa and what it requires to build an HL spa. So each spa requires a pump, requires labor, and tubing. So suppose I want to build one AS spa. What am I going to need? Well, I'm going to need 1 pump, 9 hours of labor, and 16 feet of tubing. What if I wanted to build 2? Well, then I'll have to multiply 1 times the number of spas I make, 9 times the number of spas, and 16 times the number of spas. So we can set this up as 1 times x1, 9 times x1, and 16 times x1. Now what about our HL spas? They require 1 pump, 6 hours of labor, and 16 feet of tubing. Now I'm going to go back here and make sure this matches the scenario given. That should be 12. Okay, and so this is x2. So suppose I make 1 spa of each. All right, so I have 1 AS, 1 HL. So that means the number of pumps I use has to be less than or equal to the number of pumps I have, which is 200. The number I produce of each one in labor has to be less than or equal to the amount of hours I have already paid for. And tubing has to be less than what's actually on the shelf. So this is part of setting up our linear program. These are our constraints. So the way I would write out the linear program would be to maximize profits, where profits equal 350 x1 plus 300 x2, with the constraints such that x1 plus x2 is less than or equal to 200, 9x1 plus 6x2 is less than or equal to 1566, and lastly 12x1 plus 16x2 is less than or equal to 2880. So this here is how I would set up my linear program. Now what we're going to do in the next video is we're actually going to see how do we solve this linear program graphically. But you can remember from multivariate calculus, this looks very similar to something we can solve quickly in Solver. We set an objective function based on 2 choosing variables. We have 3 left-hand side constraints that match 3 right-hand side constraints, and we can use Solver to solve this quickly. But we first want to learn how do we do it graphically first.